Okay, so I determined that the motor was bad. I took the motor out and I applied 12 volts to the motor, and intermittently it would run and sometimes not run. So I decided I'd go ahead and try to take the motor apart. And unfortunately, I didn't video that for you, but perhaps you can get the idea when I put it back together. Essentially, to take it apart, I took some pliers, and these little tabs held this backing plate on, which is somewhere around here, held this together. And so I took pliers, went around, and spread these back so there would be room for this backing plate to come off. I put a little screwdriver in here to start it, pried it out. So I got it apart, couldn't see anything devastatingly wrong in there. Often what happens with motors is the brushes don't make good contact over time. These are the brushes here, and I removed those. Again, you'll see how they go back together. And I took some of a Scotch-Brite pad. I trimmed off a little piece, and I cleaned the contact area of the brushes. I also cleaned just ran it over, scuffed up the contact area of the commutator. So I've done all that. I also observed that, I'll get to that in a minute. So I'm going to go ahead and put the motor back together. The way these were in here, it was like so. These slip through here. And I'll squeeze them all the way in with a pair of pliers. That one's in. Put the other one in. And when I had them out, I bent them a little bit so they would apply a little more pressure on the commutator. This is a little piece that came off the back of the commutator. This little disc here. I took that off to get better access when I was scuffing them with the Scotch-Brite pad. So I'll put that back on. This is going to be a little tricky to try to put these back together without, how should I do that? Without bending these out of shape too much. I'll just try to be very careful and kind of work it in. So that's there. I probably could have put a little lubrication there, but since it's back together, I'm not going to worry about it. I'll put a little on the other end when it goes in. You have to put this in place before you can put it back into the motor shaft. Now this is a permanent magnet here, and it's going to want to try to suck this inside, and you want to have to find a way to kind of hold it to keep it from sucking it back out of the brushes here. And then also you have to try to hit that little hole there. So there we go. Kind of got lucky probably. Then I line this little tab up if I can find it. Okay, there's the little tab. I line that up with this little slot here. Spin the motor to see, make sure nothing's bound up. Want to make sure that's down as far as it'll go. And I'm still fighting a little bit where that was those aren't quite spread all the way. So I'm going to have to kind of work it back in. You can turn that on. Okay, I have this set in there. It's just kind of a dry fit right now. I'll still need to figure out a way to peen these edges over so this won't come out. But before I do that, I want to go ahead and apply voltage to the motor multiple times and just see if it runs. It's the wrong connector. Well, it's running. Reverse directions. So I'm going to start and stop this several times because it seemed like there were certain positions where it wouldn't start again. You probably can't see that the shaft is turning, but I can hear it and feel it with my finger. And a reverse polarity. This motor does normally run in both directions in service, as it's changing from one far end of the settings to the other. Much quieter in that direction. And it was that way before I took it apart. I don't know what the deal is. Okay, it was failing much more frequently before, and I didn't get it to fail once there, so I'm going to assume that this is working much better than it was, and that we did make some improvements. So I need to go and bend these edges down to keep the back from coming out, and you may as well turn the camera Okay, so I took this down and put it in a vise, used a hammer and a punch, and you can see I peened these over just enough in 4 places that will keep this from coming back out. So that the motor runs freely. I'll put some voltage on it again. This is a 12-volt motor, by the way. I'm using a battery out of an UPS, uninterrupted power supply used for computer equipment and such. And so I just have leads connected to it. And so we'll just double check. And the motor seems to run fine. So there was a little piece that goes on, came off and now goes back on the shaft. And I don't believe there's a direction for it. I don't think it matters which direction it goes back on. So I'm going to get it started. Going to take a hammer, and I got a little I'm going to need to support the bottom of this without damaging these pins here. So this is kind of the way I do things. I'll just put these 2 batteries together, let those fall down in the slot. I happen to find this very nice little device that I'm going to use for a tool down at the shop. This is flat here, so I'll use that side. Apparently that's not going to work. So I'll get it started first just by getting it flush. Okay. Well, I wish that would have worked, because if I'd known it hadn't, I would have found something more suitable when I was down there. Let's see what happens if I take this. This is aluminum. Hopefully it will hold up. Oh yeah, it's going down pretty easily actually. Now before I get it too far down, as you can see it's a pressed fit, it goes down to till there was about a little less than a 1/16 of an inch with this pulled in. You notice this motor has play, but the permanent magnet will pull it, tend to suck it in. To get this off, I got these little pliers, little needle nose pliers underneath it, and just started carefully prying up. And the farther I got it up, the deeper I got the pliers in, until I came to the point to where I got an even larger pair of pliers to pull it up. Because what you don't want to do is put a force that's going to tweak the shaft and possibly bend the shaft. So that's instructions for getting it back off. So I'm going to continue to push this down. Maybe a little more. And what I'll do is I'll start here. So this is the worm gear, and it mates into this, I don't know what you would call that setup, but kind of like a yoke, really. And it goes up against that. So we'll see what kind of fit we have here, and if I need to drive it down anymore, I can do that. So far as I can tell, this just goes straight down, doesn't go into a hole or anything. And it's looking to me like I do believe it went this direction. Though I do remember seeing the one in on there. So that looks like I have it in plenty far enough. And so we'll take this out again. We'll put the circuit board in, as that goes on, has to be underneath it. All of this stuff just lays in there basically. When the motor goes back in, these contacts will fall into there. I think I'm going to squeeze these together a little bit, bend them a little bit to give them tighter contact, as things do tend to wear over time. And so we will put a little grease on here, on the end here, smear a little bit on the worm gear. This is called a worm gear, by the way. Probably pretty obvious why. And I just pulled it off. Way more grease than is necessary. And so there's a slot here, and there's barely a slot there that this slides into. And there's also 2 slots down there to line it up. The other gears do not have to be in before this goes in. And so we want to get these started. Just continue pushing down. Push those in. Get those in place. When the cover's on, that will hold everything in place. And it looks like, looking down there, that it's all secured. So the next gear that goes on is this guy. Put a little grease here and a little grease there. Some on the bottom. Smear a little on the top of the gear itself, because that'll be pressed up against this cover here. Okay, the next guy that goes on is this guy, and he'll actually go like this. One thing I think I want to do, I'm going to pull this off again. I'm going to put a little grease in the teeth here. Cameraman's laughing at me. Okay. Now this one, when I took it off, it was very tight, turned very tightly. And so what I did was I cleaned it up as best as I could. As far as I could tell, there wasn't any gunk in there or anything. I believe it was tight from the factory. But anyway, what I did was I took some sandpaper and I took some material down on this shaft here. And I also took my X-Acto knife, put that back together. Comes an X-Acto knife again. Very lightly scraped this to take some material off. When you do that, both sanding and this, you just want to be careful not to start changing the shape of it. You want to go around it evenly, so it stays somewhat round. So we'll put some grease on here now. Turns a lot freer now. It was quite hard. It was surprising to me. I'm going to put some grease on this guy too. And grease up these teeth. I've already greased the worm gear. So we'll mesh that in with that in with that. And so now I'm noticing I'm getting a little bit of movement. If I go back and forth, I'm getting a little bit of movement on the worm gear. And so I want to push this brass piece that we put on, push it out a little just to kind of tighten things up. Well, it appears like it just pushes back in, so I guess that's just how it'll be. But it's far from, oh no, that is tighter. It's far from slipping off of there, so I feel comfortable with it. This is the last gear to go on. These contact pieces had grease on them as well. I'm not sure if that's a special kind of grease, so I left that on there. I didn't want to clean it off. I don't want to replace it with this. This is just disc brake or wheel bearing grease that I'm using for the rest of it. And so, but I will use it to grease these parts, the mechanical parts of it. I just don't want to get it on the electrical part. And I'll put some on the teeth here. That's using grease and oil on contacts is a practice I've seen before. I'm not familiar with the science of it. Apparently there's a reason for doing that. It obviously could not be a conductive grease or everything would short out. But I've seen on a lot of automotive stuff where there's contacts, moving contacts, like windshield wiper motors, such things like that. They grease them. I've also seen in industrial applications contactors that are actually encased in oil. So there's some property that it has that apparently aids in conduction. So I'm going to attempt to have these line up to where the contacts are somewhere. This one goes all the way around. These two go all the way around. They're the inside. These are only on one side. So it doesn't matter. I don't have to be concerned about getting it exactly in the right position as long as I get it in a contact area, because the servo motor will just correct itself and take it to the position based on whatever the switch setting is. So now I've got that all together. Trying to think if I've forgotten anything. I've already put a little grease on these. I'll put a little bit more on this guy. This is where these gears will be rubbing up against. So we will put this back together. You can hear it snap in. Getting these guys to snap in. On some of them, like this one, when I spread it, it doesn't want to go back down, same as this one. It's not a big problem because the screws will squeeze everything together anyway, so that's not critical. This snapped in, the connector, and so we have our motor back together. So now we're going to take it out to the car and give it a little test. So I'm just going to do a dry run here. This is the wire that connects to this. I'm just going to connect it in place. Turn the ignition on. And already it's correcting itself. So I'm going to run to all the different positions. This is all the way to the left. And you can watch this turn as I change positions, and it'll stop in the proper position. So keep your eye on this. Stops. Next, it stops. Going back the other direction. And so it appears to be working.